So, you want to implement a character creation system that could make something like this? Or this? I got you, buddy. What I'm gonna spill for my eye holes here will be more of a general knowledge instead of specific details that you could apply to any engine that you're working on. Based on my previous experience, I will be introducing to you guys two approaches, which I will categorize as vertex-based and bone-based approach. Both will eventually enable you to change the shape of your character, but they work differently and you should be mindful of when to use which approach. Still following? Good. Don't you dare walk away from this. So for the vertex-based approach, we usually use something called morph target, or shape key, or morph key, whatever. If you haven't already known, our character model are made up from a bunch of vertices or 3D points, and when they are connected to each other, they form the surface or the shape of the character that you see in game, or we often call it a mesh. In the text format, it's technically just a list of vertex order and their location in the 3D space. And to understand how a morph target works, I will show you two models here. One is a default character and one is a muscular character. So how do I make your character buffier like my man here? Just simply swap that default character mesh with the muscular one. Yeah, but what if you want to make the character half muscular? Do you go tell the artist in your team to make a new mesh with that description and ruin their whole day? No. That's when morph target comes into play. It's a technique that will allow your character mesh to blend into different shapes efficiently and non-destructively. So in this example, instead of using the muscular mesh as a different mesh, we store it inside our default character with a blend weight ranging from 0 to 1. Now if we want to make the character half muscular, we just need to crank up the blend weight to 0.5. Cool, huh? You could add multiple morph target or shape keys to make your character look, for example, skinny or fat, like a mom. As I said before, each vertex in our character model has a location in the 3D space, and morph target are like offset or additive values that are added on top of each vertex location. So imagine it's just a list of each vertex and its corresponding offset. That's why when you authoring morph target, both meshes have to have the same exact amount of vertices and their orders, or else you will end up with something that looks like it's been thought out with the Nightmare Factory. And why store additive or offset values instead of absolute locations like how vertices locations are stored? Well, I'm glad you asked. So let's say morph targets are stored as absolute locations. When we apply a fat morph target, for example, the math will look like this. But what if I also want my character to look muscular? Then the math will be like this. And just imagine we're trying to apply multiple morph targets at the same time, then the math will be completely unreadable. And in a lot of other cases, the vertex position stays the same, as in the shape only changes partially. Then the offset for the vertex are basically 0, so then we won't have to store their value in memory. With all that said, I usually use this approach to change the body weight or the facial features of the character. But for changing something like height, arm's length or shoulder width, morph target won't work well at all. If you haven't already known yet, to make the character moves in game, we also need something called a skeleton, which has a collection of bones that allow us to control how each part of the character moves. And bones are usually where we attach our meshes into, for example, attach a weapon into the hand bone of the character. With morph target, we only manipulate the vertices and not the actual bones of the mesh. So if being used incorrectly, it might make the attached mesh being off from where it should be. That's why for modification that affect animation, you should go for the bone approach instead. So if using Unity, what are you doing here? Just switch to Unreal Engine already. Just kidding. In Unreal Engine, there's usually a place called Animation Blueprint, where you could add different nodes to modify a bone location, rotation and scale. But is that an ideal place to do the job? You see, the animation blueprints run every frame, and the more nodes you have in the graph, the heavier the performance. And let's say you have like 15 different sliders for different body parts and you have a shit ton of NPC in your game. That will take your CPU a lot. A better way here is to change the reference pose of our mesh, but that's the topic for another day. So there you go. You can see the comparison of the two approaches for customizing your in-game character here. Now you can start implementing whatever sicko fantasy you have for your character creator. Have fun and see you never.